Good evening again. So yes, this is building a Tellurion, an explanation of the experience of how to put that beastie together. So firstly, the obvious question, what is a Tellurion? So perhaps you're familiar with the idea of an orrery in which you see essentially the solar system going around the sun, Mercury, Venus, Earth, Mars, etc., which may or may not include Pluto, depending on which particular orrery you buy. So some manufacturers, as well as making orreries like this one, also produce Tellurions. So a Tellurion is the Earth, Moon, Sun system, if you like. In other words, it's giving the relative motion of the Moon around the Earth and the Earth around the Sun. And if it's done properly, it will include the tilt of the Earth so that you can get a number of different things out of this that you couldn't possibly get if you have a tiny little Earth and a Moon that doesn't necessarily move in quite the right way, might go around the Earth in a month, but you won't get the full subtlety of the relative motion of the Moon around the Earth and the Earth around the Sun. And explicitly, you will not be able to predict eclipses with an orrery, but you can with a Tellurion. So that's basically why Tellurions exist, so that we can get a better handle on and model or visualize the relative motions of these objects. So it can be used to demonstrate the basics of day and night by looking at which side of the Earth is facing the Sun. You can get the changing seasons because the Earth's axis should always stay pointing in the same direction, regardless of where the Earth is in its travel around the Sun. The Earth's axis should stay pointing at some arbitrary point in the sky. So that will explain the seasons. And we can see the Moon going around the Earth being illuminated by the Sun, and therefore we can understand lunar phases. But where a Tellurion comes into its own is some of the other mechanisms that sit underneath the dial there that holds the Moon. And that is, we can predict lunar eclipses and we can predict solar eclipses. And we can tell the difference between an annular eclipse and a total eclipse when it has been calibrated correctly. In other words, if it's set up in the right way, then the position, the time of the year is indicated by a dial, and it should be possible that if you start, for instance, at a particular position which you know to be one eclipse, and then run it years into the future, you should be able to see all future eclipses. You don't have to start with an eclipse, but you do have to start with the Moon in a known position before you can run it forward. This one has been run forwards and backwards quite a lot, and so it's not actually currently set to 2023 because it literally remembers where it is, and it depends how much you've been moving back and forth. So a reminder of how eclipses work, because it's relevant to what I'm about to say. Remember, the Moon will sit in between the Earth and the Sun once a month, but we don't get an eclipse once a month. And that's because the Moon's orbit is tilted by about 5 degrees or so. So in other words, for a lot of the year, when we do have a new Moon, when the Moon falls between the Earth and the Sun, if the tilt of the Moon's orbit is like this on the right, then the Moon will actually be too high to block the Sun. And similarly, when we have a full Moon, the Moon is actually too low to fall into Earth's shadow. And similarly, on the other side, on the left, if it's tilted this way, then the full Moon is too high and will miss the Earth's shadow, and the new Moon is too low and will not block the Sun. If we want to have an eclipse, then we need the Moon to be lined up along this line, which is the intersection of the plane of the Moon's orbit and the plane of the Earth's orbit. So in other words, this so-called line of nodes, a node is just the point at which the Moon's orbit coincides with the Earth's orbit. That line of nodes must be lined up with the Sun when the Moon is present at that point, if we want the new Moon to block the Sun, or if we want the full Moon to be in the Earth's shadow. So it's not just a question of we'll get an eclipse if it's new Moon. It's only we will get an eclipse if it's new Moon and the new Moon happens to fall along this line of nodes. So we need to know what the actual plane of the Moon's orbit is doing, and if that's changing, how fast is it changing? So if we can model all of that, if we can build a mechanism that gets us with the Moon going around the Earth at the right rate, and it models the fact that the Moon's orbit is tilted by 5 degrees, and we get the relative timing right, we can predict when an eclipse will happen. So that means we need a few different mechanisms in here. This particular device is all driven from one motor on the center, and the various gears ensure that things move at the relevant rate. So the mechanisms, the rate at which things move is built into the number of teeth in the various gears. So we need to know how long it is from one new moon to the next new moon, a so-called synodic month. And we also need, and that's indicated by that ring at the top there, we also need to know how long is it for the moon to go from one node back to the same node again. And that's called a draconic month, which is a different length of time to a synodic month. And that's indicated by this, perhaps you can't see, but you might have to come close and have a look in just a moment. That's indicated by this ring, which is actually tilted at 5 degrees relative to the rest of the Tellurion, so that the moon sometimes is high, sometimes is low, sometimes high, sometimes low, and the midpoint being the node. So the draconic month is how long it takes to get from one to the other, one node to the other. And there is another month, which is called the anomalistic month, which is the moon's orbit is elliptical. It's very difficult to actually make gears elliptical because they stop meshing if they're not circular. So in this particular Tellurion, the idea of the elliptical orbit of the moon, meaning it's close to the Earth and then further from the Earth, then close to the Earth, then further from the Earth. How long is it from the closest point to the next time it's at the closest point? That's not the same as new moon to new moon. It's not the same as node to node. It's a different timing. And in this particular case, it's difficult to make the actual moon move further and closer to the Earth, so the anomalistic month is indicated by a separate dial. That's important. Remember that the moon will cover the sun. If the moon is close enough to the Earth, it will appear big enough in our sky to cover the disk of the sun. But if the moon is a long way from the Earth, the disk of the moon will not be big enough to cover the sun, and that's when we get an annular eclipse. So we need to know where the moon is in its elliptical orbit, regardless of the new moon and the line of nodes. We need to know whether the moon is close to the Earth or far from the Earth if we want to tell the difference between a total eclipse of the sun or an annular eclipse of the sun. So that's why we keep track of this so-called anomalistic month. So we know relative to the stars, the moon takes 27.3 days to go around the Earth. But the synodic month is different. There's the anomalistic dial at the side there. The synodic month is 29.5 days, rather longer than the sidereal month. Draconic is a little bit less, 27.2 days, and the anomalistic month is 27.5 days. Only if we get all of those correctly geared can we hope to actually predict eclipses. Obviously, we have a job choosing the number of teeth on all of these gears to make sure they all mesh correctly and the timing is right. So it can never be perfect, but in principle, if you get it right, you should be able to predict eclipses for a few decades into the future. Not thousands of years into the future, but at least decades into the future before the timing goes awry. So all of these are built into the actual mechanism itself. So this is about building the Tellurion. How do you actually build something like that? Well, one option is to subscribe to the people who made this in the first place, a company called Eagle Moss. And you might have seen it advertised on TV, builds in weekly parts to a complete blah, 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 blah. In this case, a complete model of the Earth, Moon, Sun system. So you could, if you wish, subscribe to this. It's a very expensive way of getting a Tellurion because each issue costs quite a few pounds. And with one issue, you will get something like, for instance, the first issue will give you the Earth. Fine, okay? The second issue will give you a cog and a couple of washers and a spring. The third issue will give you a sprocket and a couple of washers. The fourth issue will give you... So you get it literally piecemeal. Each one will come with instructions as to what you do with the bits you've got. And if you wish, you can subscribe to it, get a little bit per week, and literally a magazine lands on your doorstep once a week and you say, I've got a new cog. Or you attempt to collect all of them and then say, right, we've now got all 52 bits, let's start. But basically, the entire set, in principle, I'm not going to show all 52, but that's the last one. The last one is a washer and a grub screw. That grub screw is the last thing you get. And of course, it's essential. It might well be the one that's now slipping, I don't know. But that is an expensive way of doing it, by collecting the 52 parts from the original manufacturer. Complicated by the fact that I'm not sure the original manufacturer is still making them and selling them. But let me just say what you actually get. The magazine gives you very clear instructions as to what you need. It's the clearest set of instructions. If you're used to making IKEA furniture, this is dead easy. It will give you the parts, and for every time you get a magazine, it'll tell you, we're now dealing with this cog, and there's one of them, and it comes with this magazine. And we're also going to add it to this cog, and there's two of those, and it came with last week's magazine, or whatever. So it's always referring exactly which part you've got, which each piece is numbered, so you know what you've got, and it tells you with which magazine are you going to get that. Is that one not coming till next week, or is that something you've already got? So it tells you completely what you need to know in terms of which part comes with which magazine at what point. And it tells you how they all fit together. It literally says, take this piece, offer it up to this piece, and put the 3 screws in here. You have it visually, and it gives you it in words, so hopefully there's no amount of confusion. And it literally says, take the 91 tooth gear, which is the one numbered 15, and put it in the collar, which is the one numbered 14. So as long as you keep track of these numbers, then you basically are able to put all of these things together, and it gives you this exploded view of how the pieces fit together. So an exploded view is really useful so that you can see, right, that is that, and that goes onto that, then there's a washer, then there's a collar, then there's a gear, then there's another whatever. So you can see exactly how it all is supposed to fit together, and it shows you what it's supposed to look like when you're done. So you've got the exploded view, and then if what you end up with doesn't look like that, you know you've done something wrong. You realize you put one of these bits on upside down, which can be very important. If you put certain collars upside down, then gears won't necessarily mesh. But all of that, all of the parts, the exploded view, the instructions, the full view, makes it as close as possible to foolproof. I said collect the 52 parts. That's one way of doing it, and that's the expensive way of doing it. The alternative is find the 52 parts, because there were lots of people who started this thing and then decided they didn't want it. They started collecting a few and thought this is going to be too expensive, or they started collecting a lot of them and then decided not to build it. So there are a great deal of bits and pieces available on internet. For instance, Facebook Marketplace. If you look there, you'll find people who've decided, for whatever reason, to sell their Tellurion bits and pieces. This person, I think, had a full set. All 52 pieces were available, and they were basically selling it as a job lot. Sometimes you need a bit more detective work, because for whatever reason, some people sell just parts. In other words, not all 52 pieces, but just some of those 52 pieces. Here on eBay, they're selling 46 out of the 52. I have no idea what happened to the other 6. And it's embarrassing to ask, but this particular person is selling 46 pieces, and they will tell you this number, this number, this number, this number, so you know exactly what it is you're getting, usually. Occasionally, people sell you things like this, and they say, I'm selling this stuff. And buyer beware. If it's not what you wanted, that's your problem. In other words, it was a question of taking the photo, blowing it up a bit, and saying, right, okay, so they're selling that and that. Okay, I need that. Yeah, I need one of those. Don't need that one. I need that one, need that one. And figuring out which ones are actually the ones that you actually require. This particular seller did not know what they were selling, because they thought that they were selling bits of a Tellurion. Actually, they were selling bits of a Tellurion and a few bits of an orrery. So there's actually a horrible Frankenstein model in there, because somehow they've managed to acquire a whole set which look very similar because they're from the same manufacturer, so they're all in the same sort of lacquered brass finish. But unless you happen to know what you're looking for, I know that's part of the Tellurion, and I know that's part of the orrery. And looking at this, it was a question of, well, is it worth buying this job lot? Because I want some of these bits, but I don't want a lot of others. And if you decide to go this route of collecting, some people just literally sell one piece at a time. I will sell you piece number 27, and it'll cost you £3 or whatever. I'll sell you piece number 51, and it'll cost you £2, £3, £4, whatever. Sometimes you literally just cherry pick and find what people are selling. Sometimes it's worth buying a lot, even though it will end up duplicating some of the bits you've got. You might have, I ended up, of course, with a spreadsheet saying, I've got these, I need these, let me see if I can find an eBay seller who will give me the ones I want, which is that one, that one, that one, and that one. And sometimes you end up buying a lot simply because they're selling a job lot cheap and you want 2/3 of it, the other third you've already got. So you end up with duplication. And friends and I started doing this. We're all interested in astronomy, and we thought we'd do this just as a project, so we started going online, looking on eBay, Facebook, Amazon, finding bits. And we, over a period of weeks, built up all the bits we needed, but along the way, we ended up with a whole load of duplication, because that was the cheapest way of doing it. And at one point, there was a tipping point where we said, well, we now have enough bits for a Tellurion. But along the way, we've actually got loads of duplicates. And we added it all up in the spreadsheet. And we had almost enough for 2. So we thought, oh, what the hell? Let's get a few more pieces. So we ended up building 2 Tellurions. My friends live in Birmingham. I live not far from Liverpool. So we ended up building 2 complete Tellurions, and we still have a few bits left over. We still have a few triplicates because of the way we purchased them. So as a homage to Gemini North and Gemini South, when we built 2 Tellurions, we called it Tellurion South and Tellurion North. So Tellurion South currently lives in Birmingham, and you're looking at Tellurion North sitting on the table there. And they are nominally identical. Beware, it can become addictive. Clearly, some people, by the looks of this, they are either collecting or they literally just sell spares. They literally have a spare room full of Tellurion bits and orrery bits. And in some cases, you can simply email this guy, or whoever it is, and say, I'm missing bit 27 of the Tellurion. And he'll say, yep, here it is, it'll cost you this many pounds, whatever. And clearly, this set of, it looks like mainly orreries, but there's clearly a Tellurion at the back as well. 2 Tellurions at the back, 3 Tellurions at the back, and a whole load of orreries. And they literally cannibalize one in order to complete another. If you wish, you can buy it complete. There are people who make these things and will literally send you the finished product, the finished orrery or the finished Tellurion. But for me, all of the fun is to get the bits and build it yourself. So yes, it can be addictive, and whether or not you call it obsessive is just a matter of perspective, I suppose. So my friends and I said, hurrah, we've got the 52 bits. This is the first Tellurion we decided to build. So we laid them all out on the table and took a photo, thinking this is the last time all the 52 bits will be separate. You can perhaps see that we've got the top and bottom plate of the base drum, as it were, that's got the mechanism in there. It may be a bit confusing, but we've got the Earth, which is the first piece that you get. It may be a bit confusing to see that there's a sun there and a sun here, but perhaps you notice on this model the sun is actually illuminated. You actually get one sun, which is just a piece of plastic, and another sun, which is a hollow piece of plastic with a light inside, so you can get the sun to light up. And it took a while to build the Tellurion, starting with this. Get a nice pair of scissors, because each of these is still in their original plastic. We wanted them to be mint, even though they were second-hand, so we bought them all that were still sealed. A pair of scissors will get them out of the plastic, and then you start building it, according to the instructions that's in each of the magazines. Not surprisingly, you start with the Earth at an angle of 23.5 degrees on this sort of canted one, and then it's sitting on an arm, and then you add the Moon in its synodic orbit of 29.5 days as it goes round. And then eventually the Earth and the Moon are joined at the central point by the Sun. And bit by bit, you add the various gears and the chains which take you from the drive shaft, which is underneath the Sun. The chains then drive the Earth and drive the Moon, and the central shaft also makes the Sun rotate at approximately the right speed. The Sun, of course, is fluid, so it actually rotates at different speeds according to latitude, but of course, this is just a solid model of the Sun. So you build it up over a few hours, basically. It's fun, especially if you like things like Meccano or anything which involves construction. I would recommend, if you're going to do this, do it on a table and use one of these shallow trays. I guess you get them in garden centres and other things like that. A shallow tray simply means that whilst you're constructing and fiddling and adding things, if you do happen to drop a grub screw, it lands in the tray and doesn't roll off the table. Not that that ever happened at any point during the construction. This was just me posing as if I'd lost a grub screw. The previous one reminds us that you don't need all of the tools here. Long-nose pliers are quite handy for holding some of these things whilst you're doing them up. The only things you absolutely need are a couple of small Allen keys and a screwdriver and a pair of scissors for opening up all the plastic. Everything else is pretty much optional. And it took approximately 10 hours. I think we did it in one weekend. We had all the stuff ready. It took 10 hours and quite a few cups of tea and a lot of biscuits, but basically 2 days of a weekend, a few hours in the morning, a couple of hours in the morning, a couple of hours in the afternoon. Over 2 days, it took us approximately 10 hours to put the whole thing together, and then we had to go back and start realizing, okay, that is actually a little bit high. We need to adjust that. Let's loosen that grub screw, push that down a little bit, retighten it. And it took a little bit of fiddling, a little bit of fettling, just to make sure everything meshed the way it should, and that everything was the right torque, so the motor was happy moving everything around. It's only a very small DC motor in the base of the unit. And it was enormously satisfying to put it all together, and after 10, 11, 12 hours to have a working Tellurion. Yes, optionally, you can put in the illuminated sun. It doesn't look very bright here. That's obviously a picture taken in the dark. There's no real point in having a bright sun because the shadows are wrong, because of course the relative size of the moon and the earth and the sun are all wrong. If the earth is that big, you can't have the sun its true size. But there it is in action. We seem to have a loose grub screw on the real thing, so there it is working just with a simple video showing it roughly from above. So the indicator down here tells you, are you close to perigee or are you close to apogee, such that if you get an eclipse, are you looking at an annular eclipse or are you looking at a total eclipse? The moon is going round in a Sidonic month, and it's riding on top of this ring here, which is inclined at 5 degrees, to make sure that the moon is sometimes going high and sometimes going low, to make sure that you don't simply get an eclipse every month. You can read off when an eclipse happens by looking at the various dials here, which tell you when the moon is in position such that it's lined up with a node. It'll tell you you've got an eclipse, and then you can check down here whether it's a total eclipse or an annular eclipse. That's how the eclipse prediction works. And if everything is working correctly, then the axis of the Earth will always point in one direction. It's designed so it won't keep turning as it goes around the sun. It'll keep pointing to an arbitrary point in the sky as it rotates and goes around the sun. Let me just run that again because it's such a nice video. So you can see there's a little pointer on the opposite side of the arm as the Earth is going round the sun. There's a little indicator here, which is basically something which, if you set correctly, tells you the date. Because, of course, the angle of the Earth's axis, it should be such that the axis of the Earth is pointing towards the sun in summer and away from the sun in winter. And that has to be set up correctly by checking you've got the right dates when you first put the moon into orbit and get the Earth to rotate around the sun. There's just a close-up of some of the mechanism, just because I was playing around with the video camera. You can see a reflection of the moon in that particular brass gear, and as it goes away, you see the moon is actually riding on a pillar, which is sitting on a wheel, and the wheel rides up the 5-degree tilt to give you the moon going high or low. Again, let me just run that again, because it's just a nice video. And yes, it is hypnotic when you actually see it running for real. So, to summarize, by hook or by crook, find yourself all 52 bits. The expensive way is to get it from the manufacturer. The cheap way is to get it on eBay or Amazon or Facebook Marketplace, or all of the above if you need to pick and choose and find the bits. It's a bit of detective work, and that in itself is quite fun, to find all the 52 bits. You don't actually need the magazines. Some people sell the bits with the magazines. Sometimes you can buy the bits and the magazines have disappeared. It doesn't matter because there are YouTube videos covering the construction, so you don't necessarily need the instructions. You could just go into YouTube and basically watch the video that says this is how you build the first bit, this is how you build the second bit, this is how you build the third bit. You can literally watch somebody else do it. So it's nice to have the magazines. There's a little bit of astronomy in there as well as the instructions, but not absolutely essential. And it is enormously rewarding to spend a few hours putting it together and then at the end of the day have something that actually does what it's supposed to do. Unfortunately, it doesn't travel too well because it does tend to loosen whenever you vibrate it, and the grub screws will always need a little bit of tweaking. So that's basically it. The reference at the end here, if you want to take again a handout of the slides of the talk, and again I'll make these available to Owen so you don't have to make a note of any of these. That's the original manufacturer, Eagle Moss, or at least the original distributor of the original orrery and the original Tellurion, which is sometimes called an Earth-Moon-Sun orbiter, which is a very long way of saying a Tellurion. And back issues are often available from Eagle Moss, but you can't guarantee that every one of the 52 back issues is available. There are other places you can go to, such as Partwork Collectibles. They actually sell all the parts as well. But my friends and I found that by far the best source is to go second hand. As long as they are still sealed, you know that they're not scratched, etc. If you go to Amazon or eBay or Facebook, you can find basically all of the pieces. Great fun. I can recommend it as a project. Thank you very much.